Wow, I am so tired. I did a 10K bike ride and my fitness level is disaster. Let's not go there. I I I accidentally baked some cake. Cake. Oh, green screen doesn't like the cake. Cake. Oh, this looks kind of nice. So realized my fridge is nearly empty, so I just whipped up some cake to have something to get my blood sugar up again. So shall we start this? I really need to work on the timing on this. Actually that was the screen. So where were we? Where did we leave off? I mean, we fixed the extraction of the GL program code, right? I'm still and we can draw and so that's nice, but we want the shader from a file, right? And I thought long and hard, yes, we do want a basic resource manager, but I would like to abstract away the file system as well. So the resource manager will need to load files somehow, but long term we want to abstract away the file system anyway, right? The resource manager says, give me a file. I don't care if it's in memory, linked in a pack file, on the disk file system, on a server. If it's written on toilet paper and I ask the user to type it in, I just don't care. So add file system abstraction, right? So I want something that I can tell, hey, I want this shader file. I don't care how you get it, just get it for me, right? And if you block, then you block, and if you don't block, well, so let's say step one. Let's make sure we're clean. Yes, we are clean. So let's make a directory that abstracts a system, right? And we actually touch source system rs. And usually I would in C++ I would subclass, so object oriented, but Rust is trait oriented, right? So how do we do this with traits? So let's say we have something in system that is a file system, right? That is a file system. A file system I can tell, hey, open this file, give me a directory, probably open file is enough. And then that system has streams, right? So a stream is something, a file system gives me a stream, and that stream is something I can say, hey, give me your size, rewind to the beginning, give me the next byte, or give me a memory block, or so this is basically the file star, the file pointer, if I use an fopen. So a file system gives me file streams, right? So let's go into layout mode. And I'm not sure that this should probably use a test, but I'm too lazy to write a test. So system. Well, system. Mod file system, right? And mod file system stream. So that's step one. And then let's start with a stream actually. So we have a trait, which is a file system, and my trait knowledge in Rust is like minimal. So okay, so I want a function I want to get the position. Well, I want to get the size, right? Well, maybe we just use the size getter, right? This will give me a uSize. This will give me uSize, right? It's just a trait, so we don't need an implementation. Yeah, start with the hard stuff after being super tired and not up to speed yet. That's a good idea. So we have a file system stream, right? And then we probably want the position. It's also uSize, and we have a set position, pause uSize. You could argue that this should probably return the old position, but I don't care. And then we have a, it's all read only for the moment. Let's go read only, right? And then we have basically we have a read U8, right? This will return a single U8, and this will always return a U8. Can this error out? The thing is, if I go into option here and say, hey, at the end of file it doesn't return anything, I'd rather have. Let's do it like this and pretend, okay, if some idiot reads past the end of the file, just give him zeros for all eternity, and that is valid. So basically that says, say, something rank 1 and then end of file, right? So that's the basic interface we need from a file system stream, and I probably... And let's do the same for the file system. I mean the minimum trade file system. The minimum a file system needs to do is, and now it's getting interesting, because it will return something, stream, open name, open by, so here's the thing, usually we don't open by string, because it will be hash mapped and lookups are expensive, but let's just, and this will always give me a file system stream. This never fails. That stream might end up being invalid, but oh yeah, here it's the impl file system stream, right? We, I don't know, it's still, brain is still in C mode. So that will say, hey, oh, why does it know how to? Okay, so then we have our system, right? This is our thing that abstracts the system, so we need a thing, and that's a pop struct system something, and let's just, because we know we will need it, derive debug, and we have an implementation for system, and maybe this will end up being a trait in the future, but this has something that says pop function. Obviously it has a new, right? The standard new. And this has a What we really need is a function. Oh, this is interesting because we're borrowing mutable and we might need to keep the file. So this has a function default file system, right? I can create file systems on the fly, but the system is the master of, hey, this is how you access your disk, right? So, and this unfortunately needs to, I mean, maybe this doesn't need to be mutable. Let's make it explicit for now. And this will return a mutable implementation of something that is a file system, right? So we have a default file system, and that is a file. Do I need an impl? Something that implements a file system, right? And then obviously here, too much boilerplate. Why is this still compiling? Because in our mod, in our lib.rs, I didn't hook up system yet. strst pub mod, and now I'm gonna get a ton of errors, right? Probably. Yeah. Well, only 5. File system not found in this scope. Okay, system rs. We have to use create system file system. I'm not sure if we want to. Probably we want a dummy, right? Okay, so that's better. And file system stream not found, which is fair. Yeah, base system abstraction is always a bit boring in the beginning, but what is going on here? And in file system rs, obviously, in file system we need the stream, right? So let's bring this into scope. Oh, this trait is private, so let's make this. You could argue that this should be file system. Well, I'm not sure. And this trait is also public, right? We could talk about default implementation, so okay, so default file system, obviously, so this here just returns self dot, right? And it returns the mutable reference. The initialization now is going to be interesting because we need a default file system here, right? And we don't have an implementation. So what I'm going to do is a file system. Well, I could just do this, but this probably won't work. Yeah. So nice that it tries to use AppKit to do this. Infiltrate not allowed outside of function and inherent message return types. Wait. Let's fix this one first. So what we need is a empty file system, right? A dummy file system. Let's imagine an empty USB stick. So if I do source system file system empty rs and file system stream empty.rs, right? So I go into system and actually I want to reorder this, even if it's not alphabetical anymore, but and then we use the empty here, and here we just say empty new, right? So that's part one. So file system empty pub struct file system empty and an implementation of file system empty and an implementation of file system for file system empty, right? And I'm just gonna copy that to the other empty rs because it's so close. I should have fixed the use first, right? So this will need both. We know it will need both, and the stream probably will need both too. I'm gonna ignore the unused use for now. Good that that was a touch and not an echo. So, oh, yeah. Probably this needs an empty. This probably just needs the empty. And the stream, right? Let's go minimal. Yeah, maybe don't include yourself. So this needs the stream. And minimal, minimal, minimal. So we still need to implement all the traits. So let's do that real quick too. I mean, this is easy for an empty, right? This is easy. No, for the stream. This is easy for the empty, right? So the size is always 0. The position is always 0. The set position just doesn't do anything. The read always reads a 0. It's always valid. And it's always end of file. You could argue it's always not end of file, but then a loop would loop forever. So that's the dummy file system, right? Probably we need to create this will need to create, but let's slow down. Micro steps. Yeah, I mean system rs file system. The includes here are a bit ugly. Well, the includes, yeah. So almost there. So these I have to look up, and I thought that's how you can do it, but maybe I need to do trait. And then the file system is missing an open, obviously. So the file system empty is missing the open. This is going to be interesting because the file system empty needs the file system stream empty. Right, so this will say let mute stream equals file system stream empty create. Signature to be defined, and then we just return that stream, right? We don't. Oh, this is interesting. Should the file system own? Ah, who owns the streams? I think the file system should own its own streams and close them on drop, so we have shared pointer dynamics basically. Two steps back, the file system stream empty doesn't have a create right now, so it's just boilerplate until we have it stopped out, and this is everything we write this week is v0, so the minimal to get it going, and then later we replace bits and pieces. So that impulse thing is not working. I thought that's how it worked, but maybe I'm wrong. File system empty has no new. Well, yeah, duh. We'll end up having a lot of boilerplate cut and paste code in Rust because we can't implement it in the base class. Okay, file system stream is not found in file system empty. That is fair. So that's for here. Mutability is, I'm leaning towards shared pointers, but for now, so I don't want to do this. Abstract return types are only allowed as function and inherent implement return types. So but make sure infiltrate only appears in a return type position. So that is exactly the case that it's complaining about, right? It's complaining about the exact case. Oh, let's ignore this one here, but this here. Infiltrate not allowed outside of function and inherent message return types. This is the message return type, right? This is basically defining a common trait behavior. So our trait is, it's draw here, but it's file system, right? and then we implement the trade. And then we need dynamic dispatch, yes. Object safety we ignore for the moment. Okay, so we need dynamic. Oh, thanks for telling me how to not do it. So is this just so the file system empty? Well, the file systems, the system is just a Dune file system. So I just want anything that is a file system, right? Okay. Yes, the open. Oh, oh. Obviously, all of these are. The open changes the file system, right? And probably all the ones in the file system stream. I mean, I'm gonna fix mutability in a second, but all of them are. So end of file doesn't need to be mutable, right? It's checking a status. Is valid is the same. Read is changing data. Set position is definitely mutable. Position is not, and size is not, right? And then unfortunately we have to fix all of them. As a self. Actually, let's copy these. Set pos read is valid as self. This is self. This is mutable self. And that should be nice, right? And then file system empty, obviously this is mute self. Thanks for copying and pasting the spaces. So that should be a lot better already. Boilerplate. Okay, file system doesn't implement debug, right? I mean, that's right. Okay. Rust import debug for trade, and we did that in Cheval actually. I mean, we could just implement debug, right? So steal from ourselves. Remember we did that for the element, right? So the element is basically a trade, and then we did this, right? So let's have a default. So let's implement for this, and this is a trade, and maybe we should implement the name. maybe we should do this. So maybe we need a function name which returns a str, and the same for file system type, right? I would love to just call this type, but that doesn't work. So we have a standard debug formatter, and then for the empty one, we just implement these two and say, okay, the name is just nothing, and this is just empty, right? This is the username and this is the type, so probably we need to reference that. Missing name and file system type and implementation. Oh, yeah, my bad. I always do this. I always do this. I'm wondering about this, because do I just hit dynamic? I mean, this just returns an empty, right? So this is specific. I'm not sure if that will fulfill the trait, so this would be so easy object-oriented. So let's learn something new. And then basically file system rs, maybe this just returns a file system stream. I mean, shared pointer. I want a smaller font, but then you can't read it anymore. So maybe this needs to be dynamic too. So system rs line 18. Maybe this impl is not a fan, but we're shaving down the errors. So self doesn't have a size known at compile time. Yes. A return type of a function must have a statically known size. Yes, but okay, that's the wrong one. It's the 277. That's totally useless. So okay, so this thing here is not known at compile time, right? But the box is known. And then we do a box new of this, right? I should have tested this in. So expected trait object found struct. Okay, fair. So file system empty must return this, right? And, oh, we want to return. So we can't return the specific version because we told the system we return the trait, right? But that is fine. Then we can't do upcasting, which will bite us. The trade bound boxed in and file system is not satisfied. Trade file system is not implemented. Wait, what? $19. Oh, wrong file. So this is true, so we can just unbox this, right? Wasn't it unbox? I'm at that page that I usually have blocked. Can we just dereference this? Ooh, don't kill me. Okay. File system empty line 90. Size of cannot be known. Yes, I know. Do we really have to box this? I just say box new. Dynamic dispatch in Rust is just ugly. Okay, and now the trade is saying, hey, but you said you give me a dune, but now you give me a box, right? So let's box this up. Value dynamic dispatch would be nice, right? So let's say now we should be able to ask the system. So we should be able to create a system, get the default file system, and then just open a file, right? So let's just try this in the setup, right? Maybe we want to do load configuration. So what we want to do is rs use create system, right? We use the system, and on setup we say we need to store the system, right? We need one system. So we have a system, which is a system, right? And on new, we say system new, right? And then at some point we say let mute reference file system is self.system.default file system mutable, right? That's what system does, right? So we have a file system. We do have a file system, and for now I just want to debug this, and probably we forgot to derive a handful of debugs, and actually right after that we do a to-do, our favorite to-do. Everybody has to do it. To-do just die, right? Self as an anonymous lifetime, but it needs static lifetime. Why? Is captured here. No, we just borrow it. We just want to borrow this, right? We don't want to own it. Why? Well, back to the documentation. This is element config. We did this before and I forgot. So and I know we struggled before. So this uses a factory. And then boxes that up. I'm not sure I want that. This is just a frickin' pointer, right? So should this just return the box? And should this just return the box, right? Step one, we just return the innets, right? We want to return box file system cannot, obviously the caller here. Let's say we have the file system here, right? So cannot move. So this tries to move, obviously, right? So I want to return a mutable reference to this. So this doesn't work because it's a box, right? Oh, can we just... This would be so easy with pointers. I don't know why everybody's always complaining about pointers when this is trivial with pointers and so hard with traits. So let's run this, right? So we have a panic with die, and we do have a file system that is empty, right? That should have been 5 minutes to get here. So what we want now is let file is filesystem.open test.txt, right? And then let's debug this file, right? So this should probably we're gonna hit the same problem. So file system stream doesn't implement debug, fine. So we just steal this here. And then we have a file system stream and we just implement debug for the stream. Let's say we have a name, but not a type, right? Oh, it helps us to debug and costs nothing, right? So we have a function name self str and the function file system stream type. Probably this is better. And the same, right? And then we copy these two over to file system stream empty and just implement these two. And the name is nothing to be decided. Probably the file name once we have the create implemented. And this is basically file system stream empty, right? Just to have better debug for the moment. They can override debug and add more info. So this is a die, so the file system of type empty gives us a file system stream empty. And maybe we just, we know it's a file system stream, so we just need the empty there. So maybe here we add self dot is valid this would be so nice with a ternary operator, right? But let's not have ternary operators because they improve readability. If self is valid, then we do valid, else we do invalid, right? This will come in handy at some point and we can extend it even more. So this should return valid. So this returns valid, right? So that's our empty handler. So obviously we don't care about the file system stream empty, we care about the disk file system stream, right? So let's say we want to say while not f dot end of file, let c equal f dot read u8 and just dump it out, right? Well, let's do a print, not a print line. C, and then we do a print line, right? Basically dump the whole test.txt. Okay, obviously this needs to be mutable because we and this basically returns nothing because we didn't open the file. So let's make a data directory in data. Let's actually, because we're still here, right? And this is a source code, and I actually want to make the data directory one directory above, and that's actually the Fiiish data. And then I say vim Fiiish data test.txt. This is a test file. That's not formatting, so obviously our default file system is not gonna fly, right? Our default file system is gonna be the empty file system, and the empty file system just does nothing. But we want a disk file system, right? So let's say touch source system file system disk, and disk meaning operating system file system, right? So we have a disk file system and we have a stream that's also disk, right? So let's wire these two up. And then later we'll do very cool magic with that. We could have network debug, hot loading, you name it. So I'm going to copy the file system empty into the file system disk. Disk. I'm pretty sure I foobarred up something with Rust. Let's have a file, and basically the file system disk. Let's return a file system disk, stream disk here, right? And the type is disk, because we don't want to do. So the disk is just a copy of the. I could have copied the files. So, and then we have the stream empty. So let's stream disk. And basically we do the same here right now. So the only difference between the disk and the empty is the name. Right? So if I do a cargo check, it still should compile. So the stream disk has a create, and now what we can do in the app, in its setup can decide, hey, to do make configurable via command line or environment. But right now what you could do is let disk file system, we could just say let disk file system is file system disk create, right? Obviously, we have to use this. So, we want disk, right? We want disk. So this should still work. If I didn't do anything, probably I did something I forgot. Private module. Oh. All of these are public, right? Yeah, I could have used multi-edit. I know. File system disk doesn't have a create. Oh, it has a new. Obviously, it has a new. So we knew this. That means we create one. Duh. So this still works, but basically changes absolutely nothing, right? So this is still empty, and I want disk here. So I need a way to say pop function set default file system, right? And that gets the file system, and that is something that implements file system, right? And then I can just say here, I say, okay, by the way, self.system.set default file system. So basically we say, hey, nice that you had one so far, but we want a different one now. This probably is not going to work because we need to box it. Wait. Unused variable fs. Oh, probably we need to do something with that. We just stop this out. So this is just self.default file system equals box new fs, right? We take ownership of it. We move it. Sorry about the chewing. My body is crying for energy. I have to take my dinner out of the fridge. So we want this to take ownership of this. So we pass this in. So you probably see this stream later and go like, what the hell is he doing? So now we have a disk file stream here, right? So we said, hey, we create a disk file stream. So the disk file stream will actually open files from disk, right? So when I do and I only will, so when I do a create here, this will actually open a file from the physical disk. So this create will need a path, right? A file name. It is a path, but file name. I mean, nobody is using this yet, so oops. Oh, the file system disk, obviously. This here somehow needs to create the name, and that is the full name, right? To do. So this will be the full name. And technically, we don't need to store this, but we want it, right? File name string. We just store it for debugging. Only need it for better debugging. Technically, we don't need it, and it's a waste of space, but it's super nice to file name to I'm never sure about toString and toOwned, to be honest. I just don't know. Stream still working. So, but that means in the name here, we can just return a reference to self.filename, right? I want to run it, not check it. Wait. File system stream. We get the name here, right? And the type is disk. Oh, here is to do. I missed that visually. So how do we get the full path name? And this is going to be interesting, right? I don't want to hand out full path names, so the file system disk, when I create it, needs a base path, right? Base directory, right? Base is string. So we just copy that in and say baster is baster to string. toOwned probably is good enough. So here I do something like format, comma. Probably it's just this, right? This slash this. And that's basically self.baster, comma, name, right? So full name is a base working directory plus the name. So now the create will fail because, oops. Oh, nice one. Nice one. And this now says, hey, could you please give me a base dir name? I mean, so this somehow needs to know what this is, right? So this is base dir plus, and what we want it to be is, that's going to get interesting. I think we want this, right? we want this, right? We want this directory, so I could just say this, but then I say copy, oh, okay, exa-l, and then I want this, right? So I could just say, hey, okay, I know what I want. I just paste this in here. And when I run this, then and a lot of people do that in development, and so this is the text file, and if I try to open this, this is a text file. So, but you check this out on your box, so I check this out on my Windows box, and this is not gonna fly. So I want the current working directory, right? So rust get cvd standard env current dir. Okay, standard env current dir. Sounds good. Let's say let's cv. That still means if you run it from the wrong directory, it will not work. So it needs the subdirectory magic, but that's okay. So debug cvd. And now we start to mix pass buffers and strings, but I don't care for today. So CVD is this, which is nice, and then somehow this is the result pass buffer. Oh, we need to unwrap that, but if we unwrap that, oh, okay, so we unwrap that, so get the okay away here. If we don't have a current working directory, we're probably in trouble anyway. So we have this now, and that is a parse buffer, and a parse buffer, we did that. We could just pass in the parse buffer instead of the yeah, but and then we have the toString lossy, right? We just do toString lossy on the pass buffer, and then the current working directory cwd. Okay. Let's cvd equals cvd dot. So we do have the CVD, and basically all we need to do is I can just say, hey, just use this, but this is not correct. So let's say let data dir equal format. Yes, this would have been easier with a pass buffer, but I'm making examples. So basically what we say, yes, from here, go one up, and then it's fish data, right? Fish data. Sounds like fish fight. And then here we just use data dir. Come on. Just have to fix something real quick. I need to change the chat settings at some point, or need a moderator, or both. So let's see if this is correct. I mean, oops, what did I do? Yeah, maybe don't do two things at a time and finish the line of code you're writing before running it. No, I don't want to install an update now. So let's see. So this file exists and is the one we want, right? So we get rid of this, Well, we want the die here, and so we're still getting the empty line, but now we can implement the disk file system, right? So we have a file system disk, and when we open a stream, and we need to retain this stuff. It's probably don't want to go into shared pointers, so I just say, hey, whoever does it knows what it's doing, right? So we probably need lifetime support, because this lifetime can never be, well, this lifetime here can never be bigger than. So if we have a lifetime here, right? And have a lifetime here, this has the lifetime, right? But let's not go there right now, because we're handing out a box, and in the disk file system case, it's something that's valid forever. But imagine we have a file loaded, a package in memory, and then we destroy the package but still have a file handle out there. That's not a good idea. So this is working, and then we have so the stream is opened. So this actually gets a file name. So shall we just open the file? Shall we just open a file? So this is just a standard file, right? Oh no, this is file, right? And open is always, for now we have only read support, right? So maybe create here is bad, and we rename all of these to, maybe rename all of these to open. Yeah, maybe we should. File system, file stream, disk, file stream empty, file system disk. Obviously open should open one, right? Yeah. Not sure. Not sure. Let's see if we broke it accidentally now. No, still working. So this is actually doing the opening, right? So what we can do here is basically examples, reads the contents. So basically we want to do this, right? And no buffers and no nothing. So Well, actually, let's do file as an option of, what is the type of open? Where's open defined? Open is a file, right? Open is standard FS file, so let's actually use that. So this is the file, right? And we might have one or not. And then we change this. I like to change this because let mute s equals this, and then we just return s at the end, and then we can fix it up later because that makes it easier to move code around. So what if we say so back to the open. So open returns the result, right? Open returns the result. So we can just do if let okay f equals, whoa, no, we don't unwrap here. We just say s dot file name, right? If it's okay, we say s dot file equals some file, right? That's all we do. Let's try to actually open the file. So we killed our debug. Maybe we might want to overwrite debug, but so let's actually go here and say let's say print line test file has size f.size, right? So this will probably return 0 right now. We're not gonna get, I need to get my food out of the fridge so I go hungry. So test file has size 0, right? So what we need to do is basically, we want to basically say if let sum f equals self.file, else we return 0, right? We could cache or anything. Let's just return 42 if we actually manage to open the file. Oops. Yes, we want to borrow this here, and actually we're not using it, so we getting a 42, and if I actually go here and change the the file name here, then we probably get a 0. We get our dummy stub, right? So we get the test file has a 0, which is nice, right? So, but we don't want 42 here, right? So how do we get a file size? Seek, read. I mean, we could seek to the end. Actually, I think that's the only way to do it reliably. So we do is, come on, internet. So we do a seek, and that gets a seek from, and that we seek to the end, right? Oh, okay. So we can do seek from end, right? So this is not optimal, right? But what we can do is, and hopefully nobody will ever need this. So we seek from the end, right? We seek to the end. You say match f seek. Well, we do if let okay. And what will it return? It will return a result, so okay u64. So new position, right? If the seek complete this the new position, okay, equals this. I need food. I start to hit the wrong keys. Else, maybe we should cache the size, but I hope nobody does that too often. Else we just return a 0 because something is broken. We cannot seek. So in this case we return the P, but basically what we need that old position equals f dot pos, and then we say f dot seek from start. That's the old school way to get a file size. You scroll all the way to the end, and then imagine a tape. That's the only way to get the size. And there's probably a more modern way to do this, but I never even checked the pos. Oh, step 1, we need the F here, right? That's probably 3 of 4 arrows, and I never checked the position if that actually is valid, and it probably is not. So seek from, obviously if I want to use seek from, I need to include it. I need to use it. And that's why we abstract all of this away, because I just want the position and the size, right? So star, did I actually type star? Method not found. So, oh, it's still the, I need to load the preload in, probably. So pos not found, seek not found, cause I need to use this, right? I don't like that prelude pattern one bit. And actually in this space it says it's a U64. I mean, in the one place where size would make any sense at all, it used. What have they been drinking? Pos not found in file. So what is... so it says stream position, not pos. And this is the result, right? So it... So... no, I want to mix it up. So basically in the arrow case, as we said, we squelch everything. In the OK case, we just... my monitor says I'm working too much, right? So in the arrow case, we just return 0 and everything, all bets will be off. Don't use size. I mean, nope, this is just for demonstration. Cannot borrow as mutable. Why not? As it is not declared as mutable. True. Oh, we should have used the mute in the... So here is what we will do. Here is what we will do. Inside here, inside of here, down here we just return self.size, right? Inside here we get the old position. And we say self.size equals, otherwise we do nothing, right? I would love to move this in here, but then we have the f is borrowed foo bar, so I'm not gonna do this. I need to still learn so much Rust. Oh, obviously S. That means we get the size of everything, but cannot borrow as mutable. Why? Oh, because it... Fair enough. Borrowed here, I've move occurs here. Come on, Rust, you're killing me. Okay, so since we do it at the start now, we don't need the old position, right? We just seek to 0. We know it's at 0 at the beginning, right? Alright. We open files at the start. If it was an append, that would be different. Move occurs here. Oh. I still didn't take my... Okay. So if we run this now, we get a test file has size 21. So exa text file has size 21. Hooray! I need a 15-second break. schwere Kost. So, I mean, now we can just go and implement all the rest manually, right? So, if let sum, if let match, what do you prefer? F equals self.file, else it's 0, right? And then we just say, we just remove the code, stream position. So if let OK p equals f dot stream position, then p else 0. That should cover the position, right? Okay, okay. As usize. But apart from that, so we can get the position. Yes, we need to borrow here, and probably we need to make it mutable. Why the hell is stream position mutable? Why the, what? I mean, the seek I get. But why are all of these mutable? I just want the position, so why I'm... yeah, I could use file metadata, but I don't want to, because on some consoles you can't get metadata. And sorry for the bot bot slapping you there. But can you tell me why stream position needs mutable? I mean, we're just gonna cheat. So we're just gonna say pos is usize, right? And here we say pos is 0 and just track it ourselves, because I'm getting... I mean, set pos obviously is an interesting one, right? So set pos ends in, and this is mutable. So here we could say f dot, well, I do the, why do I delete this before I, if let sum f, then we do self dot file, and we borrow this here, else we do nothing and assume it is still safe. So in this case, we say f seek from start, seek from start pos, probably su64, because the one place where size would make sense. How's your Sunday going? And now we actually say if let OK p equals f dot stream position. Then we say self dot pos equals p as usize, else we do. Oh, we just did a seek, but this should never trigger, right? So we do nothing. Cannot borrow as mutable as it's not declared mutable. Line 47. Can I get some pointers, please? Okay, I've had it. I tried. I really tried. Part 1. I want to keep this generic, and to be honest, it's just old school, old habits basically. And it works everywhere, while metadata can be a bit tricky and you should not seek anyway, so. No, this is just for debugging anyway, so we will stop it out in release. It's been a long day. I should make my dinner and stop this. Because I'm making very, very, very stupid mistakes right now. You could just take it. Wait, wait. What am I doing? My brain is gone. So if I run this now, I mean, we're not using it. Yeah, I should have matched the self file as mutable. But the interesting thing is, it still works. So let's do a quick. We should write some test cases ideally, but so this is f size. Pause, and actually I want to do this twice. Doing this in the middle of this is, and actually what I could do is now f set pause. I don't know. Let's set it to 10, right? I mean, that's not showing that the underlying file has been moved, but at least. So test file has size 21, and we believe we have moved by 10. And then I also want to check the position at the very end here, right? And the read is not working yet, so it still is position 10. But the nice thing is, if I go to the disk file stream and say end of file is basically self dot position is larger or equals self dot size, right? And this will be false all the time now because our read doesn't change it, so we'll loop forever. We will loop forever, right? So let's fix this read. So I shouldn't have fixed the EF before the read, but basically we have a file. No, let's seek. We have a file, so how do I read it? Read a single character from it. Create with options, sync all, sync data. Set lengths, meta. We could just have used metadata here. This will become clearer when we implement the other file systems that don't have the underlying system. So that has a read implementation, right? And read. How do I read? How do I read? And do it use read exact? I just want one simple read to end, read to string, read exact by ref bytes. I probably just want to take. So we could just take one, right? I could just take one. I mean, do I really want to do that? Do I really want to use a take to get a single byte? I'm leaning towards the read exact. No, we do the read because the read gives us feedback, right? The read gives us a result, so we do the read. I mean, it sounds a bit silly to say, hey, let mute buff equal basically 1 U8, right? And then we do the old dance of, well, I should have done that first probably. So the non case, it will just return 0. Right, and in the sum case, we create the buffer, and then we say f dot read, and we match this f dot read mutable reference. So this gets a mutable reference. I just want a byte. Right, so the result could be error, in which case we ignore it and just say, hey, 0. Right, or it could be okay, n, and probably n should be 1. Right, but let's ignore the n here and say, in this case, we return buff 0, right? But we also say self.pos plus equals 1. This is the simplest reader whatsoever. Oh, nice. My bad. Hardest way to read a character from a file. So, oops. We've our formatter here. Oh, how do I get a character from U8? How do I get? We could create a string from UTF-8. I mean, this is just debug, right? So we could just do C. Oh no, no. String if let, and that returns the result. If let OK as string from UTF-8. This is a hack. Nobody will ever use this, right? So wrap it in an array, and in this case we just print the S, right? I'm taking dangerous shortcuts now. You mean? Yeah, this probably could work. I always forget that. So we get test file. Wait, we get. Oh yeah, because actually this is a test file, but we search to 10. Right, so we search, the search works, and obviously if I make this a bit smarter, I mean this is test code, right? So this is gonna go away soon. So I think we're not loading shaders today, but hey, test file. So what's still missing is the read is fine, the is valid basically is self.file is sum, right? Maybe that's aiming a bit too low, but for me that's okay. And we have our disk file system abstraction. Probably want a little bit more than U8. And then we just remove this. And that's our file system abstraction. Oh my goodness. I mean, we need more, but this is a good start and should be enough to read shaders at some point. So I have some ideas. So for example, if we go into the material now and say, okay, this is our fragment shader, right? So this is Wim Fiiish data default fragment shader.glsl, right? So default fragment shader. We could just load this instead of a test file, so that makes a bit more sense. I mean, that's what we're after, right? Default frag, and did we just name our vertex shader fragment shader? Yes, we did. Ah. Nice going, buddy. But this basically means we can load, and actually let's set the position back to 0 here. I mean, it's just proof of concept anyway, but we're, whoa, oh, lucky me. I need a break and some food, I guess. Oh, I still have cake. So we can load, well, we can load bytewise load our shader from disk. So that's nice. Mm. We have a basic file system abstraction that obviously needs more, right? So our file system stream. Read U8, yeah, but probably we want like read more than one U8, or read into string, or read all and cache. But worst case with read U8, we have it, right? And we can easily abstract this, add more stream types. I mean, this was a bit rough, and what I don't like is the file system. Well, the file system disk here, it doesn't keep track of its streams, so this needs some kind of handling for potentially open streams. And then we have shared pointers, so hmm, well, standard pointer is RC. RC is for non-threaded, and we probably do we need the box then still if we have the RC? That just makes it ugly for the caller, right? Because the caller then has to lock all the... This would be so easy with pointers. This would be trivial, so... but future retain info of open file stream file system streams in file systems to allow cleanup, e.g. via RC or ARC, right? But we have a basic file system abstraction for reading, so I'm gonna tick this box. And probably we're gonna skip the resource manager today and just have a material builder that uses system to load the shaders. Okay, so I could just replace the box by RC, you're saying? We have like 2 minutes of stream lag, so I'm gonna eat a bit and wait. Starving, sorry. So we added the retain info and added this. We use the file system stuff in Fiiish mostly for, for the setup of the disk file system. Maybe extract that out of the function, but this needs cleanup, and then we do an example load, which is fine. We added this new stuff. We added the shader here. We added the test data. We added this system. We added various file systems. So add file system abstraction layer, add disk file system. Yeah, so given that we want to have the game running in a week, well, less than a week, 5 days, I'm gonna skip that for now and kick myself in my behind later because I skipped it now and it will be harder once it's splattered everywhere. But we're gonna skip the resource manager. Well, actually, I'm gonna rebase this. I'm gonna push this, and then I'm gonna. It's all open source on GitHub if you want to have a look. I'll actually take probably I take a 5 to 10 minute break to prepare my dinner because it will need a while, and then I do another hour or so we get the. How does any of this sound to you? So I'll be back in a moment. I am sorry, due to some miscalculation in the cooking time, I need 5 more minutes. I'll be back. Sorry about that. Can you actually let me check something with the audio real quick? I'm not sure if you can hear that. Can you? Okay, that seems to be okay. So I need to have the oven running in the background, otherwise. Actually, let's do a quick check on my Windows box, because I pushed all of this, so I can just fetch and rebase. Luckily, all the groundwork we're doing right now, you only ever have to do once. So okay, so this is also still working on Windows with the existing problem of the viewport not resizing. So oven should be off in 5 minutes. I need to stir something, and then we're good. So where were we? I would love to have a basic resource manager in place, but we're gonna cheat around that. Let's create the material builder, because I want something. I mean, if I close all of this, right? Let's close all of this. So right now our renderer has exactly one hard-coded material in his vector, right? So in this setup, we just create a material and no way to configure that in any way. So why don't we create a builder for materials? We still will create one material here, but we want to inject some information in that. So basically what I'm thinking of is, okay, let MB equal material builder new, and then we just chain, I don't know, with a name default, right? And then we say let material equals MB build with system, and then this, oh, this is interesting, because we will need the, so here's the thing, the renderer app setup. So, the app setup has the system. So where's the renderer created? So the renderer is created here. So the renderer could get the window at the system, right? So that's okay. So we say this will need a system. I mean, we need to pass this around a lot now, but that's fine. And then we just say system, right? How about this? And then we just push the material on the stack and be done with it. And then we can chain more stuff in here. Oh, thanks for the follow, Silence. I didn't see that was happening while I was gone, so sorry. But thanks for the follow. I mean, you'll get a lot of notifications next week. So this allows us some flexibility, right? So obviously this will need the system here, but that should be easy. So the system is some base foundation layer that we will probably pass around a lot. So I'm not too worried about that. In something like Unity, you would make that a singleton, but we'd rather pass it around explicitly. Okay, touch source renderer. This is interesting. Material builder.rs. Do we want the material builder? I don't want it in the same file as the material, right? So in the renderer, you're just gonna say mod material builder, and then we say pub use material builder. Yeah, thank you. So we go into the material builder and say pub struct material builder. That has an implementation for material builder. Thank you. And that has a pub function new, which returns a self, and that's just self. And then we have a pub function with name that basically gets a self and passes through the self. I think something is burning. I wonder how many streamers actually burned down their house because they were trying to cook while streaming. So with name, and basically this will be removed from here at some point, built with system. So this has a pub function built with system, self-reference in the system, and that needs a mutable system. And this will create a material, right? And right now we just call material new basic material. Thank you. For now we just call material new. Material new, right? And that probably needs, actually I want to do this here for the material as well. I'm not sure I'm happy with that re-export pattern yet. But the material renderer base use create renderer material, right? All of this is stopped, so okay, so the renderer setup needs 2, and the system is not found in the material builder, which is fine, right? Create system rs. So that's one, and then the Fiiish app setup. The renderer needs the self.system, right? Oh, actually I want as material, and then I want as material builder, and then I want this to be gone. Yeah, and the material builder probably needs a self, and that just passes through the self for now. Because it does nothing, but that's fine. This function takes 0 arguments, but 1 argument was defined. That's true, because we just throw away the name for now. This was just an example how I would like it to look. So in theory, we changed nothing, right? Yep, this is still working. But that now means, let's say this has a name, which is a string. This name is just string new, and this is self dot name equals a name to string, right? So we can set the name now just in the builder, but just for completeness. Oops. This is just using a builder to create it, right? I would love to have a friend class or something. Oh, obviously this needs to be a mutable self. Fair enough. So this is still working. So what I really want to do is, I'm not sure what I really want to do. I mean, we could say with name, and then just say with vertex shader. And what was our GLSL thing? .glsl thing default underscore vs. So default underscore vs to glsl and same for the fragment shader, which I will create in a second. Right, so what we could do is default fs fragment shader, and that's in the material right now. So this is what we're using right now. So let's copy this. Not changing too many. So this. Obviously we have to support that in the builder. So we just copy this with vertex shader. This is basically vertex shader. It's just a string for now, and then we will extend this as we go, right? So I wish there were default initializers. Right, so with vertex shader says vertex shader is this, and with fragment shader is basically with fragment shader. So this is fragment shader, just wrapping it up. So how do we inject this information into the, basically, we could change the interface here. Right? Do we want to? Do we want to? Yeah, I could derive default. That's actually not a bad idea. But maybe making it more explicit. So my what I'm currently pondering is I have all the info here now, so how do I transport this into the material here? And I'm leaning towards doing it something like this. And then just do add vertex shader. Something is burning again. And then just vs. Right? And then do add fragment shader. I mean, long term, we have something like material configuration anyway, so fragment shader, and then we just say m.link. I mean, right now VS is empty and to do read from, so this is VS and this is FS. I mean, that could mean we don't, our program, well, our program will still be valid in so we could have a pop. I want this to be a add vertex shader new itself vs is a str. Then we just say self dot program add shader. Basically this, right? Well, it's not constant anymore, it's vs. Let me say the same for the fragment shader. I'm not sure yet about the abstraction we want to use here. And then the pop fn link is just mute self, and that is just a self.program.link, right? And that means we don't have a program right now, right? Yes, because we tried to compile this, so now we have to load the... And I'm going to do this manually. I mean, the material builder knows the vertex shader's file name, right? And the fragment shader file name. So what we can do is don't kill me. This is just to prove something. This is a string, right? And then we have a mute. Vertex shader file is basically system.default file system mutable dot dot open open self dot fragment shader, right? Not sure I like how the abstraction turns out. I mean, so let's see if this all works to this point. I mean, the shader is broken, we know that. I expect it's true. Oh, where is that? In here. So technically it should be fragment shader and file name, probably. So I do a cargo run. We will see the debug once it's there. So where's the debug? So here. So this is a debug. Obviously we still need to load it. And I want to manually do it here. So basically say while VSF end of file. Well, basically while not end of file. We say can be append. Well, first we have to say c equal vsf.read u8 as char, and then we append that character, right? We will have a helper in the file stream that just loads the file into a string, right? No append. How do you append to a string in Rust? Do I have too many tabs open? Yes, I do. I can push. Okay. It's push, not append. Really? So this looks like we got something, and the linking failed, but the log lengths for the and basically this was the point I was trying to make, is we could just repeat this here, but cutting and pasting code is not my kind of game, right? Failed linking shaders into program. Wait. Why? So this failed linking shaders, but the log length for the shader fragment is already broken. So are we loading the wrong file? Yes, we are loading the wrong file. What did I do here? Yeah, load the fragment shader as a vertex shader and the vertex shader as a fragment shader. Probably wasn't the smartest of ideas. And we have our materials loading from disk, and just to prove that, we go into, oh, we have the default fragment shader here, and let's get rid of that ugly red here, shall we? So this is more green and blue now. And if I do a red here, that's actually reflected. And if I use the default vertex shader and say, how about just adding 0.5 to the X position, right? Moving it to the right. So that also works. So congratulations, we are loading a shader from, I'm wondering if we should have a default shader baked in, but no, maybe not. Maybe not. I leave this in for one commit, intentional, no. But that means if we don't call these here, we'll use a program that doesn't exist, right? It's just fine for me. You could add error handling that says, hey, stupid. But wouldn't it be nice if we could just say, instead of this while loop and this, let's turn this around. Wouldn't it be nice if we could just say, and the thing is we only need a slice, right? So we technically don't need a string, so the file could buff. So what I really want to say is, wouldn't it be nice if you could say FSF as string? I mean, str would be nicer, but then for the disk-based stuff, we need to buffer and the lifetime and args. So I'm just gonna do an extra copy here. Gonna copy this, because if I go to my file stream file stream treat. Well, basically we say read as string, right? And that will return a string. And yes, we named it differently here, so read as string. And then we can just say, that will tell us, hey, the disk file stream is not implementing that correctly, my friend. And then I go to the Rust book. And look for default trait where is implementation? Defining shared behavior. So basically default implementation. So I could say there's an optimized version, but to use a default implementation, oh, we can just have an implementation? Will this just work? So can we just provide an implementation here and say string new? And that would mean the file streams could overload this and have a better implementation, but I mean, technically, we know what we need to do, right? We need a string, and then we fs at the end. So basically, we say, hey, and obviously it's self, and it's this, right? And this is just s and s. So we could just do this, right? I hope. So that works. And then if some file systems have a better version, they can just optimize that out. I mean, this is creating a new string, while it could probably It's good enough for me, and it makes this much more readable, right? So I can do the same here and say vs is vsf as string and just remove this. And we could, yes, we could just chain this here to the end. In theory, we could even just put it in here, but I'd like to be a bit more explicit. So all the 2 hours of work to get here actually paid off, because, oh yes. So what if we had 2 different materials? So let's go, we can go different routes. I mean, we ticked off the to-do, but what if I had a default fragment shader that said white fragment shader, right? And then I go to white fragment shader, and that just does a full white here, right? So I could go into the renderer and say fragment shader, let's not do this, let's use a white fragment shader, right? But I only want my mouse white, I don't want everything white, right? I want selective material selection. This looks half as fun as the other version. So, and actually I don't want, so what we could do is here in the app we could say, hey renderer, just a Siri renderer, use material, I don't know, maybe they have names. What? Rainbow. And then down here we have use material for the mouse thingy. We have use material white, right? We could just do that, but that's not really what we want, because then we have to keep track of the materials. What we really want is to say, hey, I want this effect, right? So we could have a effect that is rainbow, an effect that is white, and then we could let's say we had a material that rendered textured. So you set the material and you set the texture, but you have to keep them in sync because the material owns the draw call, right? So if you have 2 different textures, so a material is a combination of a texture, render effect, which is the shaders, and probably uniform. So if I change a uniform, that probably means, that's interesting. But all I'm saying is it would be nice to control the render effect from here, but not like this, right? But then in the renderer, we could just build multiple materials, and then in the use material, we just say, okay, use the other one. And then we have this, where we do the add triangle. Actually, this 0 is the active material, right? So when we say use material, all we have to do is switch the material by name. Well, basically, we have to find the material that can render the current stuff. So that's food for thought. I probably gonna I mean, we have the material builder, and we have a custom shader from file, right? So I'm gonna move this down. And then I want to allow material switching for renderer, right? That's next on the list, but that's not now, so I added the to-do. I pass in the system in the renderer because we need it. Pass in the system and use that to build the default material and just instead of just where's the create here? So here, just creating a default one, so I have control. So this is the renderer, this is the material, which is much more lightweight now, but has an interface for the builder, which I wish it could be protected or friended. We have a reader string, which will come in handy. We have the default fragment shader, the white fragment shader, and the material builder. Add material builder, load shaders from file, add white shader. Alright, so I'm going to commit this, I'm going to rebase this, I'm going to push this. It's still in the usual place. So I'm going to run this, go to my other machine and check what Windows says about what I just did. What does Windows? I really have to do some rewiring here so I can show you what's going on the other screen, and Windows is still working as well, so that's nice. So with that, I'm not sure, I might do an hour later today, depends on how dinner goes, but we still have the whole week and we're making good progress. I wish we were at the texture triangle point, but we are not. But once we get to texture triangle, we're getting into game land, I believe. So, thank you for being here. I want to see the fish on that screen, right? So thank you for being here. Hit follow. See you soon. Bye-bye.